Cool. Hi, everyone. Thanks for being here today. Some of these empty rooms sometimes at conferences remind me of the early pictures of Andreas Antonopoulos when he was preaching Bitcoin to like a room with like one or two people sitting there. DeSci tends to go through these waves of like adoption. So like maybe Walker, you would agree. Maybe 4 months ago the room would have been full. But I think it also has to do something with this being one of the first events of the week. And so, yeah, super nice to meet all of you. My name is Paul Kolhaas, CEO and founder at an organization called Bio, and also at Molecule. So, why are we here? So broadly, I think we invest into crypto because we believe in sovereignty and in liberty and in open source access and freedom of speech. And because something is being taken from us kind of slowly and silently over time. So specifically the inflation that we're seeing in the world today through our governments. And fundamentally, kind of, I believe that science and medicine are really trapped in similar power structures. So biopharma as an industry is kind of like this is too big to change. Similar as like the Fed or similar as like the banking system. And taking a US-centric perspective, it consumes about 18.5% of US GDP. Which is nuts. 9% of that actually goes to drugs and pharmaceuticals. And it's really entrenched by this kind of 19th century era patent system, which many people say or believe is really outdated. So the patent system is actually a massive hindrance to innovation. So in our current world today, treatments and recurring revenue really dominate healthcare. The system that we've kind of created needs lifelong customers, and it actually disincentivizes cures in many cases. So Goldman Sachs once asked in a famous report that they did, is curing patients a sustainable business model? And so in this report, they analyzed a drug that was just issued by GlaxoSmithKline, and because that was a new hepatitis C drug, and that hepatitis C drug effectively cured the patients. It was a 6-month treatment, relatively cheap, and but by launching it, they essentially invalidated or like made the rest of their existing drug portfolio irrelevant. And so Goldman Sachs essentially downgraded the company. I think even the CSO or the CEO at the time was fired because they developed a cure that worked. And through doing that, essentially killed their own customer base. Moving away from the patient perspective to the scientist perspective. Scientists today spend 80% of their time applying for funding and 20% doing the science. That's kind of a statistic that we often hear. And you have to imagine this was the case in software development. Like if as a software developer, you had to apply for funding every time you needed something, and then it would take ages to hear back from the government whether you could build that code, and then yeah, so that's essentially the world that we live in on the scientific side. So our fundamental hypothesis is that most of the world's scientific talent actually remains untapped. And more broadly, that today we live in a time of science friction, not of science fiction. So there's a lot of upward potential actually. In crypto, we often look at this utopian view, like if only this and that had happened, we would live in this like solarpunk future. Well, the reality is we'll only live there if we actually invest into scientific innovation. This is another cool example. This was a scientist that treated her own breast cancer with a virus that she grew in the lab. There's a case report published in Vaccines in August outlines this scientist called Halsey self-administered a treatment called oncolytic virotherapy to help treat her own stage 3 cancer. And she's been cancer-free now for 4 years. And she chose to kind of self-experiment on herself and did this really under the radar and was really stigmatized for it. Ultimately, there was a report then published in Nature. But had that report not been published, no one would ever have known about this because no one wanted to talk about it. And so if some of you follow Inter Intellectus or Vittorio, he's a really great commentator. He says, scientist does science, cures cancer. The science establishment says, no, you can't do that. And then you wonder why scientists are leaving academia. And so open source science is actually fraud and frowned upon, and like self-experimentation. And so ultimately, I think this is where crypto gets really interesting, in like enabling self-sovereignty around science and enabling permissionless science. So what do we need? We need permissionless science. I think to usher in the next really age of kind of scientific innovation. And so we come at this problem from two sides. On the one side, we've developed an exchange for on-chain scientific IP. So IP is the kind of the base carrier of science, and to bring science on chain, and essentially make it liquid and open. And then on the other side, we help create scientific communities. So many of you have probably heard of BIO, and so BIO is a curation and liquidity launchpad for scientific communities. And so we bridge DeFi, decentralized finance, into decentralized science, and essentially enable scientists, patients, investors to fund research and essentially build on-chain portfolios of novel IP in all sorts of scientific areas. And we typically call these entities BioDAOs. So if you Google like what is a BioDAO, you'll find a lot of examples by now of these types of entities. So BioDAOs create value by essentially building on-chain science token or IP token portfolios, and then they can directly commercialize them, either to their own communities. So HairDAO, maybe some of you have heard of HairDAO. If you suffer of hair loss, HairDAO is the first global decentralized community dedicated to hair loss. We funded a piece of research with them in the beginning of 2023, and it was a repurposed thyroid hormone. The DAO funded this for about $120,000. The IP was ledgered on chain, and now they then ran a decentralized clinical trial with it. And at the beginning of this year, they launched their first online store, where this thyroid hormone, it's already FDA approved, is now being sold across the United States. I think that's nuts. Like, a bunch of people got together online, funded something, and it's 4 to 5 times better than the next closest hair loss product on the market. They published a preprint with all of the data. And so this is an example of a community directly commercializing a drug or a therapy that they've developed. In other cases, obviously the development life cycle is much longer, and in these cases, BioDAOs partner, for instance, with pharma companies. So VitaDAO famously got an investment from Pfizer. Now I'll talk about one of their assets in a minute. But it's very basic. So you have funds that flow into the treasury of a DAO for the issuance of a token. There's a community that then actively vets and funds novel, interesting projects. And then later on, that IP can be commercialized and brings back funding into the treasury. So this was just in 2023. 2024, it's been more, but in 2023, we really, after the success of VitaDAO, we launched 6 more of these DAOs. Since then, actually, we've launched another 4 or 5. There were 2 that are actually launching at this very moment. One of them is SpineDAO, a leading network of spine surgeons worldwide, and another one is a DAO called MicroDAO, focused on mycology and intellectual property around fungal research. But yeah, these are some of the leading DAOs that we have in our ecosystem today. And so what is BIO really doing? BIO is kind of blending DeFi and DeSci together to create a new category, which we call science finance or sci-fi. One of the biggest bottlenecks that we really see in science is how capital is attracted, how it's managed, and how it's deployed sustainably over the long run. And that's where we think crypto has an incredibly powerful role to play. So how does BIO work? In BIO, token holders curate DAOs into a launchpad, and they then run through a series of milestones. We automate their tokenomics, and so token holders curate which DAOs get accepted into the system, and then these DAOs can leverage a variety of fundraising mechanisms. One could be an auction, where their token is offered at a kind of a fair launch mechanic. Another one is through a bonding curve that works similar, for instance, to like a virtual protocol. So these are some of the DAOs that launched recently. Curetopia had a really successful raise in in February this year. Qtopia, for instance, is focused on rare diseases. Started by a Harvard MD PhD who spent 10 years in the rare disease ecosystem. He successfully brought rare disease therapeutics to stage 3 clinical trials. So he works with families all over the US. Rare diseases, you typically have 500 to like 1,000, maybe 2,000 patients that suffer from a given rare disease. However, he's discovered that the mechanism, like kind of like the how do you operationalize drug development for these individual communities, is very similar. Another DAO that we recently launched is focused on quantum biology. Our leading researchers out of MIT, and they're building the world's first quantum microscope. They're trying to understand processes like photosynthesis. Fun fact. It's absolutely crazy. I think it's absolutely crazy. We do not understand how photosynthesis works. Like all the green plants out there, we have solar panels and everything. We understand it somewhat mechanistically, but really we can't replicate it. It's impossible for us to replicate. And the theory behind it is that photosynthesis, among as many things, is based on quantum biological processes. Another one that we launched recently is focused on long COVID. Yeah, cool. So what is bio actually then? What does bio represent? Bio really represents a growing portfolio of IP tokens that are backed by scientific IP. And so you can go, the slide is a bit outdated, sorry about that. You could go into each individual DAO, and each of the individual DAOs has a range of intellectual property tokens that essentially represents its portfolio. And we're going to look at and VitaDAO's portfolio, for instance, so it's now funded research for over 3 years. This was status as of, when was this, mid-November? So mid-November, roughly, VitaDAO's IP portfolio is valued at 18 million. But VitaDAO's only raised 10 million in total. And so these DAOs are actually productive. Like they're consistently generating growth for their IP portfolios. And the interesting thing is, so Bio essentially gives you now governance over each of the individual DAOs that are in this network, and each of the individual DAOs govern a portfolio of IP. Ultimately, IP is really valuable for pharma companies, for industry, to develop something. This is what innovation and drug development typically looks like today. So this is like a typical innovation cycle within an organization. And the reason why I'm bringing this up is this process today in biotech or in pharma to get a drug approved takes up to 10 years, and it costs up to $3 billion. And now we can ask, what is the reason? Like, why is this so slow? One huge reason, and I'd actually love to chat more with someone from Cancer DAO, because I often use cancer as an example, is cancer is something that affects humans globally, right? Yet we have so many companies that are spending billions of dollars doing research in complete silos, like trying to kind of dig for gold mines of IP, rather than operating together kind of in a globally shared, open scientific landscape. Like if you think about science, like scientific innovation, scientific data should be openly shared to advance it as fast as possible, like software. Yet it's not. We live in a completely siloed ecosystem, and that's what massively drives up development costs. And so the thinking is, so these are typically innovation cycles within one organization, and the idea of these biodas is, what if we open them up globally? One core mechanism that we've developed that actually achieves that, like, so how can we take all of these little tiny ideas and put them on chain so that more people can work on them, is fundamentally an IP NFT. And you may have heard about this. So an IP NFT is pretty simple, actually. It's a legal contract, like a real-world legal agreement that essentially turns it into a real-world asset. Typically, for instance, between a university and a sponsor. Like, could be between a university and a DAO, the legal entity that represents the DAO. Could be between a group of investors that want to fund a specific piece of research. Then it's a smart contract that controls the token. It's metadata JSON that contains essentially contains the publicly readable, discoverable part of the IP, and then it's all of the encrypted data, the secret sauce that you don't want people to see. And so the IP NFT in that sense acts like a kind of a decentralized Google Drive, pretty simple, where you can share access control to participants, for instance, to other scientists that are in the DAO, but not essentially invalidate the IP by making it open. The next step for this is actually then you can now fractionalize the IP. So first you start out with a one-of-one NFT, and then we've created something called IPTs. You can think of them as sub-DAOs now. Like if a DAO has a really strong research project that it's working on, what many of our DAOs have done is they've then done follow-on tokenization, where now individual subunits of the IP become tradable, or you can exchange them for work or funding. So yeah, IPTs can be exchanged for work, funding, or contributions around individual research project. And I'll walk you through a little case study that I think is really interesting. So in May 2023, the investment lead at Pfizer suggested actually this project to VitaDAO, which was mutation-specific codon suppression for aging and longevity. It was an in silico study. So in silico initially means just computer simulation. Essentially, this is like a novel mRNA gene therapy, and which was extremely moonshot. The DAO funded it for roughly 90,000. And then the initial data that came back was really positive. But so you have to imagine the DAO purchased all of the IP for 90,000, right? The initial data that came back was very positive. And then the DAO decided to do a follow-on funding, but still because it was so risky, the DAO was like, let the community fund it. Let's see what happens. And so there was a sale that raised, this goes in here, that raised roughly 300,000 in June last year, so about 10 months ago. And about 50 token holders participated. In these DAOs, if you own Vita tokens, for instance, you can now participate in these like you can call them pre-sales, or like sub-issuances. And then started trading on Uniswap at a 1.5 million FTV, roughly, with that 300K, and since then the research has been ongoing. You can kind of see some of the price development here. So the Uniswap liquidity pool stabilized at roughly 3 million FTV. And following that, further and further data drops happen, and new data continue to be released about the project. And so now what happens is now you have a micro community that is very actively looking at the data, that is actively joining the data drops. They have some kind of, often they have privileged information, so they can join calls that others can't. And we think it's a really interesting example. So the research continues to be financed, and small T's. The research team is actually here this week, and they're meeting with the Abu Dhabi health regulator to see if they can get it approved for a clinical trial, which would be massive if that works. I think this is a really cool example of financialization and what it actually does in terms of like discovering and moving an asset forward, right? Because now also you have token holders here who are like, what's happening? Give us updates. Did you look at the data? Let's look at the data again. They can make suggestions. And essentially the funds around this project are managed through Snapshot and a multisig. Cool. So in summary, we are building towards a world where scientists spend 80% of the time doing the science and 20% applying for funding. Where anyone can fund and participate in science independent of institution and geography. Thank you. Yeah.
Thank you. So you've been using this acronym IP a lot, and I take you use it for intellectual property, but it's a very general term, and it usually means one of four things. It's either trademarks or patents or copyright or trade secrets. And if I understood correctly, this is something like trade secrets, that these scientists generate something that they only tell to somebody, and they are paying for it in some convoluted way. Did I understand it correctly?
That's broadly correct, yeah. So we typically utilize like sponsored research agreement or contract research agreements. And the end result of those contract research agreement is you have a legal agreement that defines someone did the research, right? And someone owns the research, and there might even be a split already within that. And then all of the data is owned by the contractual parties. What you can now do with that is you could take that, you could go to a patent office and be like, hey, look, I own this data, it was produced here, and then you can file for a patent with it. You could say that it is a form of a trade secret, yeah. It's kind of the basis that you would use to file patents. Yeah. I personally find patents very boring, and I really don't think it's where the future is. However, if you want to work with industry, meaning with pharma companies or other biotech players, you kind of need to adopt a part of the current system. I think it gets much more interesting. So we have some of our newer DAOs are, for instance, focused on nootropics. Nootropics are like cognitive enhancement supplements, in essence. But they can be used already. They can be used for a variety of indications. For instance, there's certain nootropics that actually work very well to treat the symptoms of Alzheimer's. And there's no patents, right? And so now the plan there is to directly go into commercialization, meaning you can have an online store. These substances are they're like supplements, right? They're unregulated, and so that's kind of the other pathway. But if you want to play with industry today, unfortunately, still you need to work with patents or create patentable IP. And yeah, what we do is we push the patenting process as far down the line as possible, because that actually increases the value of the IP. And actually, our hope is with something like IP NFTs, and this is already proving itself, our hope is that because you've encapsulated the IP and because you can now create, you can issue tokens around it, you can use it for fundraising, but you don't need a patent that is typically in an equity vehicle. That already massively helps the scientists. Yeah.
Thank you.
Hello. Great talk, by the way. Really good.
Thank you so much.
So you gave that example of that woman who cured her own cancer, right? Do you think that these DAOs would be the way that humanity as a whole cures cancer?
I think we have. I think at a very high level, I think this is potentially a much more viable path toward medicine and scientific development. The speed at which the DAOs are moving is much faster than biotech. Sure, they might be much less professional, right? In a certain way, because building in Web3, building a DAO is messy, it's political, but it's also building public, which is so new in this field, right? For scientists to build in public and we are trying to enable to build in public while still maintaining commercial viability. So to your question, I think we're quickly going to see more innovation emerge from these DAOs and actually big headlines. The thing also with people ask DeSci, what has it achieved? What does it do? It's science takes a long time for outcomes, but then the outcomes are huge outlier outcomes, which really can change people's livelihoods, change people's health, so one reason why I'm very bullish on the space is you have very extremely innovative thinkers that have operated at the fringes of scientific development up to date. Some of our earliest DAOs were focused on longevity. Longevity even back then was still a relatively fringe topic. It's less fringe now. Longevity or cryonics. And cryonics makes sense if you believe in space travel. And then it's okay, when will we have space travel? Probably someday. We already do to a certain degree, but and then we're currently working with Ed Boyden, for instance, who's one of the leading neuroscientists at MIT. He runs his own, the Boyden Lab. He runs a lab at MIT. He wants to build a DAO with us. And there's other, we just got in touch with Shinya Yamanaka, the Nobel Prize winner for, Yeah, Japanese, yeah. Nobel Prize winner who discovered the Yamanaka factor. So yeah, the quality of people that are actually continuously coming into the space, because the current scientific funding model is so broken, is very high. I think it's an incredibly difficult thing. Like building a DeSci is very, very hard, but I really think it's worth it. I think crypto needs much more of these use cases to really succeed, and for people to believe in science again. I think that's something really, it inspires me.
Yeah, honestly, I didn't know what DeSci was until you started talking. I was about to leave, and then like you started talking, it caught my attention, and now I'm like, oh, this is awesome, man. This is exactly what science needed. I used to study chemistry at university, and I wanted to go into like cancer cure research and that sort of thing. But then, like you said, I saw all the bureaucracy and all that BS that's involved in like getting funding and that sort of stuff, and I immediately was turned off by becoming an actual chemist. And so I went into software engineering, like Web3 in this space. And now this unites those two spaces very nicely, like, the innovation and the decentralization of Web3 with with science innovation, like, which was being, what's called gatekept this whole time. And like you said, this is the way forward, 100%. And it's amazing what you guys are doing. So yeah, good stuff.
Thanks for staying.
Well, it's great. But I'm a bit worried about how these funding decisions get made by popularity rather than scientific merit or expertise. You have a comment on that?
Yeah, I wouldn't say it's, so the funding decisions get made through, so the funding decisions get made through typically scientific review committees within the DAO. And so it's not that these DAOs operate more like technocracies than they do as like open democracies, where like anyone can suggest a project and it's really hard for it to not get funded. And so the DAOs are pretty rigorous with regards to their spending and how they allocate capital. And typically the people that run the DAO on the inside are very, very scientifically savvy. And then ultimately, it's like, it is a capitalist system in the sense that, like, I think a capitalist system in the sense of that, like, crypto is fundamentally very capitalist, right? It's like trading behavior, and people follow the money, and and one thing I still think, we haven't had that yet, but I think the funniest science is the most likely to get funded. Meaning because you're in crypto, I think things that naturally speak to a crypto audience are more likely to receive funding.
Yes,
than
but that's
others.
what worries me.
Yeah. Well, so yeah, but it just means, I don't know. One day we might have like, but that's ultimately something that you can't really change, right? I think we might have like, I don't know, a synthetic biology project with like, for cats, for a cat with like pink ears, and like that suddenly gets like 5 million funding, and then someone else is like, oh hey, I've been trying this cure for cancer for like 2 years and no one will fund it. It's difficult to change those things. One thing that I think would be really interesting is actually for layer 1 networks to consider to consider delegating staking rewards to like funding basic research, in a similar way that the government, like if we consider blockchains to be like nation states or like network states, a government dedicates about 5% of its GDP to funding basic research, right? And then it doesn't really discriminate. Well, it discriminates by needs, but it's like, it just gives out that money to like basic research all over a country, right? It goes to the universities, scientist-funded things. I think something similar in crypto could be really interesting. Cool. Thank you so much.